Welcome back. Let's continue with the setup. So to prevent us from rewriting all of the code that we've written over the last few sections, let's write some notes here. Now we've got the versions of Torch and Torch Vision we're after. Let's import the code we've written in previous sections so that we don't have to write it all again. So if you recall in section 5, which is going modular, we've got PyTorch going modular there. The whole premise of that section was to turn our most useful notebook code and we put it in the going modular directory. And we have going modular. And we have these scripts here: data setup, engine.py, modelbuilder.py, predictions.py, train.py, utils.py. Predictions.py is actually quite a new one, but that's okay. We want these scripts in our notebook. So we want them available here. So we can do that by cloning this GitHub repo, then sorting it out and making sure we have access to the going modular directory over there. So if we go to, this is PyTorch Transfer Learning, note, this might not be V2 by the time you watch this, it might just be PyTorch Transfer Learning. It will have the same sections. So we're going to go to getting set up. We've already written this block of code here. You might not have needed to if Google Colab has updated to have the Torch version and Torch Vision versions that we needed. But now let's get started with our regular imports. So I'm going to copy this here rather than rewriting all of this. And we'll also set up device agnostic code. So I'm going to copy this in here. And what this is going to do is import all of our regular imports that we've used so often. And it's also going to try and get a few packages such as Torch Info. Torch Info is a great way to get printouts of our model, view summaries in PyTorch. This is a package here, available on GitHub. If we print a summary of our model, we want to get something like that so we can inspect our models. That's going to come in handy later on. And it's also going to try and import the going modular directory. And if it doesn't exist already in the Google Colab notebook, which it won't, it's going to download it from GitHub using this code. So git clone, then it's going to move the PyTorch Deep Learning going modular into the current working directory with the dot. Then it's going to remove all of the extra files we don't need from PyTorch Deep Learning. And then it's going to, from going modular, import data setup and engine, which are these two scripts here, engine.py and data setup. Contains functionality for creating PyTorch data loaders for image classification data. We wrote this in the going modular section, so section number 5. And the same thing with engine.py, contains functions for training and testing a PyTorch model. We've got train step, we've got test step, and we've got train. So rather than rewriting this every single time we start a new notebook, it's very helpful to put them in helper scripts like what we've done. And so this is just one way you can get scripts from, say, a GitHub repository into your notebook. So let's run this. See what happens. It couldn't find Torch Info. So it tried to import Torch Info, and that doesn't come by default with Google Colab. So it's going to import Torch Info for us, or install it with pip install, and then it's going to import it. The same thing with going modular here. It's going to try and import the going modular scripts, and if this try block doesn't work, it's going to download them from GitHub. So we've got cloning into PyTorch Deep Learning. It's copying all the objects. Now if we come over to here, we've got the PyTorch Deep Learning repo. That won't be just updated quite yet, but that's going to copy everything from here. We don't need everything from here. We're just after the going modular folder. So we'll come back. I'll just clean up these tabs. We'll wait for this to run. Beautiful. So it's downloaded all of it and resolving deltas, checking out files. Beautiful. So now if we refresh this, look at that. That is magical. We've now got going modular. We've got going modular. And we've got the scripts that we're after. So we've got data setup and we've got engine. So if we wanted to go data setup dot create, is it going to give me autocomplete? Create data loaders. There we go. And if we wanted to go engine dot train, do we have access to engine dot train? Yes, we do. And if we look into engine dot py, I nearly said engine dot train, we have the train function that we wrote in the last section. So that's the whole reason we're doing that. So we don't have to rewrite all of that code there. And now we just want to make sure we have a GPU. So a few steps to get set up here, but once you've done this a few times, you'll know what to do when you're starting a new notebook. So set up device agnostic code. And if we were working locally, like on our local machines, we could have all of this already set up. But the reason we're continuing to use Google Colab is because we get a free GPU. Not everyone has access to a GPU on their local machine. So set up device agnostic code, CUDA.is available, else CPU, and we'll check the device. We'll make sure we have a GPU. Beautiful. And you can check what GPU you have with NVIDIA SMI. So I have a Tesla P100, which has 16 gigabytes of memory. That is a great GPU. Because I pay for Google Colab Pro, you don't necessarily need Google Colab Pro, but just I use Google Colab Pro because you're more than likely going to get bigger, faster GPU than if you use the free version, because compute isn't free. And so Google provide Colab for free, but if you use the free version, you don't necessarily always get the fastest GPUs all the time. That's just something to keep in mind. So we've got our notebook set up. We're ready to do some transfer learning. Just keep in mind, if you take a break and come back to your notebook, you will have to rerun these import cells and getting set up cells. But we are ready to go. Let's now, in the next section, we're going to get some data. We need our pizza, steak, sushi data to build a transfer learning model on. So I'm going to leave that there, and I will see you in the next video.